When you have an object spinning around a circle, it has angular speed. The angular speed is going to be the angle it moves through in radians divided by time. One thing to remember, sometimes they'll give you the angle in revolutions, and which is perfectly fine. That's angular speed, because revolutions is how fast you're turning. But we have to remember there are 2 pi radians in 1 revolution if they chose to do it that way. Hint, you're going to see that. The other thing is the linear speed, how fast you're actually going, if we, rather than in a circle, but how fast would you be going, is S over T. Well, S would be your arc length. So in other words, it could also be R theta divided by time. Now let's take a look at a problem like that. It says a typical vinyl record has a diameter of 30 centimeters. When it's played on a turntable, the record spins at 33 1/3 revolutions per minute. Notice 2 things. Number 1 is the diameter is 30 centimeters. Our formula uses radius, so the radius is 15 when we do this. Revolutions per minute, that's your angular speed. So in question 14, the problem says, find the angular speed in radians per minute of a record as it plays. Round your answer to the nearest tenth. Well, in other words, this is just a unit conversion. You're not really doing anything here. We know the angular speed is 33 1/3 revolutions per minute. I want to rewrite that in radians per minute. Well, what I told you from the previous page, in 1 revolution, there are 2 pi radians. Well, 2 times 33 1/3 is 66 2/3 radians, or pi radians per minute. Oh, so in other words, in my formula, 66 2/3 is my angle. That's my angle in radians. So we'll probably want to use my calculator at this point. Let's take 66 2/3 times pi. The way to take 66 2/3 in the calculator, go 66 plus 2/3 in parentheses, and then we'll take that times pi. And you get about 209.4. We get the right term up here. So we get 209.4 radians per minute. A lot of times we don't even write radians, but I will this time. Now on example 15, I want to find the linear speed of an object as it spins in centimeters per second. So we know the formula for linear speed is theta divided by, is S divided by T. I was doing angular speed. Well, S is R theta divided by my time. My radius is 15 centimeters. My theta from the previous problem is 66 2/3 pi. And then my time, now this will, let me rewrite that. That looks terrible. 15 centimeters times 66 2/3 pi. And I'm going, and my time was in minutes, wasn't it? But the only problem is, in this problem, they want centimeters per second. I've got the centimeters, but I don't have the second. So I got to change my minutes to seconds. So we're going to say, in 1 minute, there are 60 seconds. In other words, you're going to spend a lot of times doing unit conversion on this stuff. The pre-calc formula is pretty basic. So now we're going to take 15. Nope, got the wrong thing again. Oh, I'm just going to take this answer times 15, 66 2/3 pi times 15, and I'm going to divide that by 60, and I get about 52.4 centimeters per second. I'd like you to pause the video and do example 16, and then come back and check. Okay, welcome back. We want to find the angular speed of a carousel in radians per minute if the diameter is 6 feet and it rotates at 10 revolutions per minute. Well, notice, just like the previous problem, they gave us the angular speed, didn't they? It's 10 revolutions per minute. So I know my angular speed is 10 revolutions per minute. I want to convert revolutions to radians, so I know in 1 revolution there are 2 pi radians. I'm going to get radians per minute, so at this point I'm going to get 20 pi radians per minute. Well, 20 pi, I'm pretty sure, is 62.8. But let's show you. Calculator, please. 62.8. Yep. There's your answer.